Hello. So in the last lecture, we talked about Gibbs free energy, and we talked about this master equation here, which relates delta G to delta H and T delta S. And we talked about how the signs of the enthalpy change and the entropy change have variable effects on the sign of delta G. And in these two cases here, it depends on the relative magnitude of the two terms to determine whether or not the reaction is going to be spontaneous. So now I want to do an example that kind of illustrates this concept using a chemical reaction. And that chemical reaction is the Haber-Bosch process, which is used to manufacture ammonia, which is a crucial ingredient in fertilizer. So this is really responsible for feeding much of the world. So in that process, we combine atmospheric nitrogen with hydrogen gas to make ammonia. And here I'm writing it as a balanced reaction. Now, you could look up or calculate the delta H for this reaction, which is minus 93 kilojoules per mole, and the delta S for this reaction under standard conditions, which is minus 198 joules per mole Kelvin. And I'm giving these to you as you would probably calculate them because usually entropy values are given in joules and enthalpy in kilojoules. So this is a situation where both of these terms are negative. So going back to our little chart that we made last time, when both of those terms are negative, we have to really look at their relative magnitude to determine whether the whole reaction is going to be spontaneous or not. And my question for you here is at what temperature will this reaction be spontaneous? Will this reaction be spontaneous? And the reason I'm asking that question is because, looking back at our chart, this is a situation where if the temperature is low enough, we are going to be able to achieve spontaneity because this term will be small enough for the enthalpic term to swallow it, essentially. So to answer a question like this, at what temperature will this reaction be spontaneous, I need to go back to my master Gibbs free energy equation. Delta G equals delta H minus T delta S. And I want to think about what the border of spontaneous and non-spontaneous is. Okay. We know that if we have a negative delta G, then the reaction is spontaneous. If we have a positive delta G, then the reaction is not spontaneous. So what's the border between negative and positive? Why, it's zero, of course.